There's a lot of variation in human skin color, and skin color also has diagnostic properties as well. Let's start talking about skin color. Melanin, we already know, made by melanocytes, packaged in melanosomes, taken up by keratinocytes. Melanocytes convert tyrosine to melanin. Tyrosine is a basic amino acid. As long as you're eating food, you're getting tyrosine. Ultraviolet light in sunlight or in the tanning bed increases melanin production. Again, remember, ultraviolet light is harmful. It can damage your DNA, cause cancer. So your body produces melanin as a way of trying to protect you so you don't get cancer and die. Interestingly enough, you see some people that have really dark skin, other people have very pasty white. Everybody has roughly the same number of melanocytes. It's just the amount of melanin produced, all right? So, and if you look at the lower right, you can see historically people that come from the equatorial regions have much darker skin. Whereas people, as you get towards the polar regions, like up in Wisconsin, all the cheeseheads and stuff like that, they're all pasty white. That's because, again, in terms of your genetics over a period of time, if your ancestors lived in a place where there was a lot of sunlight in the equatorial regions, then you were sort of programmed to make a lot of melanin. Whereas you live up by the pole, you don't. So it's very natural. There are no other differences. Skin color doesn't have anything to do with intelligence or athletic ability or anything like that at all. It's just that basically historically, either you lived in an area where there was a lot of sun, your ancestors, or in an area where there's not nearly as much. People vary in color. I'm sure you've noticed this. Some people have kind of a more yellowish color to their skin. Other people tan. Some people almost black. So there are actually two kinds of melanin. Eumelanin, the root word eu, the prefix here, EU, means true. The true melanin is a brownish black. Pheomelanin is a reddish yellow. And historically over different parts of the world, you can see some people have more of a yellowish skin, some people have more of a reddish skin, some people have more of a brownish skin. That all has to do with the relative proportions of eumelanin and pheomelanin. And they've just changed over the genetics of human beings over hundreds of thousands of years. People just genetically have more than one than the other, and that's the variation in skin color. Freckles, or liver spots as they sometimes call them, are just melanocytes in a patch. You've seen old people have those spots all over their hands and their arms. I've got some now too. I'm 70. I got a bunch of those on my hand. It has nothing to do with your liver. It's just they're the color of liver. All right? Doesn't mean you have liver disorder. It's all melanin. That's what it is. Freckles, same thing. Albinism is an inherited lack of tyrosinase. Remember, words that end in ase are enzymes. Tyrosinase is the enzyme that converts tyrosine to melanin. Well, some people are born with a gene, a genetic defect, whereby they cannot make tyrosinase. Therefore, they cannot convert tyrosine to melanin. So those people have what's called albinism, and they're often called albinos. Vitiligo is an autoimmune loss of melanocytes. So autoimmune is a type of disorder in which your immune system attacks your own body. Your immune system is normally supposed to attack outside invaders. Sometimes your immune system goes wonky and starts attacking your own tissues, your own cells. So in the case of vitiligo, your immune system starts attacking melanocytes. Who knows why? Wonky, weird, it happens. You may have seen that. You may have seen people with light patches on their skin. It's not unusual at all. I'm sure you've seen somebody with vitiligo. Wide variety of colors in the skin is due to the three pigments of the dermis. So melanin, we've talked about from melanocytes. What are the other two? Carotene from orange vegetables. So what's an example of something you can eat with carotene? Carrots. Yeah. So carotene, when I was a little kid, I loved carrots. I just thought they were awesome. And my mom figured, what harm can I do to let him eat all the carrots he wants? So my mom would buy bags of carrots, and she didn't restrict me from eating them. She told me I could have a carrot whenever I wanted. So I ate carrots like crazy, and guess what happened? Yeah, I turned orange. My mom freaked out, took me to the doctor. Oh my God, I gave birth to an alien. The doctor said, has he been eating a lot of carrots? My mom said, yeah. And the doctor said, okay, well, that's it. And that'll be $100. So, carotene, yeah. When I teach in class, in the classroom, I teach Bio 201 in the fall. I always, we cover this in like August, first part of September. So I tell people it would be so awesome if everybody in the class started eating like a whole bag of carrots every day. And by the time Halloween gets here, we would all be orange. And we could take a picture of the whole class as orange. I don't know why I can't convince people to do that. It's never worked. But I think it would be awesome. Have a whole room full of orange people. And then what's the other one? Hemoglobin. Hemoglobin is the pigment. It's the protein. That carries oxygen in your blood. So hemoglobin, a protein formed of chains of amino acids, and then there's a heme group. It's an iron atom, and that's what the oxygen binds to. What happens when oxygen, so iron, what happens when oxygen attaches to iron? What happens if you leave something made of iron outside in the yard and it rains? Yeah, it rusts. It turns reddish colored. So that's what's going on. Hemoglobin is red. That's what gives your blood the red color. And that's because when oxygen binds to the iron atom, it makes red. So notice people, even people who don't eat any foods with carotene, that would be hard to do, by the way. A lot of dark leafy green vegetables like spinach and kale and stuff have carotene in them as well. But people, the pasty white cheeseheads from Wisconsin, even if they're not eating any carotene, they still won't look actually white. You notice how humans look kind of pink. Why is that? Well, that's from the hemoglobin. And why is it pink and not red? Well, because it has to shine up through all those layers of dermis and epidermis. So the red diffuses, and by the time it gets to the top, it's just kind of pinkish. So when you see people with different skin colors, keep in mind you're seeing all three of those things combined. It has to do with the amount of melatonin, the amount of melanin, the amount of carotene, and the amount of hemoglobin. And that's why there's such rich diversity in human skin color. It's awesome. Here you see tan lines from typical summer activities over on the far left. Water skiing, you got to wear the vest and everything. Mountain biking, you got to wear the wrist pads and stuff. Scuba diving, you got to wear the scuba suit. Rollerblading, the elbow pads and the knee pads. Engineering, those people don't get out much. Tennis, yeah, so. Skin color pigments, so let's take a look here. What's going on in this picture? I'll give you a hint. These are two people from the same tribe. They share a lot of genetics, and they come from the same region of a certain place. And yeah, what you're seeing on the left is someone who has albinism. They're not making melanin. So look at their hair. What's going on there? Why is that color? Yeah, that's carotene. See? So carotene also forms colors in the hair and in the skin. So I think it's awesome that person's wearing a sweater that matches the color of their hair. If I had hair that color, I would try to find clothes that match it as well. I think that's really cool. And then here, Johnny and Edgar Winter, they have albinism. Johnny and Edgar Winter were rockers from the 1970s. They had a big top 40 hit called Frankenstein. They're from Texas. But they're famous albino brothers and awesome rock and rollers. They produce some pretty cool music. And what's going on there? Those are freckles. And every place where you see a freckle, that's just a big cluster of melanocytes. That's all you're seeing there. So, no big deal. Just in some people, for some reason, the melanocytes all cluster together. Or the melanin, at least. The melanosomes all cluster together. So that's what you're seeing. Just bunches of melanin all in one big blob. That's a freckle. And here's someone with vitiligo. Vitiligo, you can see, again, autoimmune. The immune system is attacking patches of melanocytes, and so there are patches where there's no melanin. Notice how it looks pink. Why? Hemoglobin. Yeah. And there's an albino deer. Isn't that cute? There's somebody's shoe. That's how small it is. When I teach in the classroom, people go, oh. I say, yeah, as soon as they took the picture, they killed it and had it for dinner. No, that's a terrible thing to say. But I say it anyway. I'm a terrible person. Albino animals, so albino camel, is that awesome or what? Albino kitten with blue eyes, and I've looked this up like 20 times and I can never remember it, but it's actually a genetic disorder where it goes together. They're albino, they have blue eyes, and they're deaf. You can Google that and have some fun with that. There's an egret or a heron of some sort. Albinism can be partial, so there you see a squirrel, it's part albinism. There you see a penguin. Again, partial albinism. There's some pigment, but not all. That looks so cool. Albino peacock. You know, if I'd been drinking heavily and I walked home and I saw this, I would swear never to drink again. I would go, oh my God, I promise I will never ever drink Sotol again. Albino giraffe, again, partial albinism. Albino gorilla, that's creepy right there is what that is. That's creepy. Albino tigers, Roy and Siegfried, Las Vegas. One of them just died. I don't know. Albino cobras. Is that cool or what? No, notice pink eyes. Because again, melanin is what makes up colors in the eyes as well. Albino owl. And an albino hedgehog. They're so cute. Bunch of little baby albino hedgehogs. Okay, so diagnostic properties. Yeah, skin can tell you things about what might be going wrong. So color of skin and mucous membranes can provide clues for diagnosing certain homeostatic imbalances, such as jaundice. So jaundice is a condition in which you get a yellowish color to the skin and the whites of the eye. So the person on the right there, that's a person with jaundice. That's a buildup of bilirubin in the blood. Bilirubin is a pigment that comes from the breakdown of the heme groups in red blood cells. Bilirubin there's actually biliverdin and bilirubin. Biliverdin is green, bilirubin is yellow, and that's what happens. Jaundice often comes about, you can see it in newborns as well. Also seen in people with liver dysfunction from hepatitis, malaria, sickle cell anemia, and so on. So it's the liver that conjugates the bilirubin, and so if the liver is not working well, then it can't process the bilirubin. It actually takes the bilirubin. Why is it called bili? Because the liver uses it to make bile. So if there's liver dysfunction, it can't use all of it to make bile, and therefore it stays in the blood and it builds up in the blood. That causes the yellowish color to the skin and the whites of the eyes. So oftentimes, not always, jaundice can be a sign of some kind of liver dysfunction. Hepatitis, hepa, root word means liver, itis, inflammation. Hepatitis is inflammation of the liver. It can be caused by bacteria, by other parasites, by viruses. Malaria, same thing, a protozoan that attacks the liver. Sickle cell anemia. So we talk more about that in Bio 202. I'll leave that for Bio 202. With babies in the upper left there, sometimes babies are born with what's called hyperbilirubinemia. You should be able to decipher, to dissect that word, hyperbilirubinemia. Hyper, too much, bilirubin, emia, in the blood. So what happens is, you notice like when you boot up your computer, it takes a little while for the whole thing to finally finish. Well, it's kind of like that when you're born. Sometimes when you're born, your body, all your internal organs are still kind of like booting up. So sometimes the liver is still booting up, and it's not processing all the bilirubin. So babies will get hyperbilirubinemia and they'll look yellowish. Nowadays in the hospital, they got rooms. They use phototherapy, got big bright lights, and they put the babies under the bright lights, and the presence of the light will help decompose the bilirubin in the blood. My youngest son was born with hyperbilirubinemia. Back then, they didn't have the fancy room with the lights. So you know what we did? Low tech. We put him by the window. Yes, and after a couple of days by the window, all that cleared up. So consider that, because if they put your baby in the room with the bright lights, that will be a line item on your bill. It's probably like $14,000 to use the room with all the lights. Put it in by the window. Low-tech rules, okay? Windows, sunlight, works. All right, so cyanosis. Cyan is blue, so cyanosis is where things turn blue. So a bluish color to the nail beds and the skin. What happens is hemoglobin, the pigment that the protein, the pigment that carries oxygen, when it's full of oxygen, it's bright red. As it loses oxygen, it gets more of a purplish bluish color. And so cyanosis is a sign that you don't have sufficient oxygenation. Now, there can be lots of causes. Typical would be heart disease, lung disease. Hypothermia can do it. People who are freezing to death. Because what happens is when you get too cold, your body pulls the blood into your core, and there won't be as much up by the skin. But normally, you see the person in the upper right there. Now, we say that person has bluish lips. Now, it's not sky blue or powder blue, but that's more blue than it should be. And the baby in the lower right, see how the baby is all blue around the mouth? With little babies, this is a very dangerous sign. It means this baby is not getting enough oxygen. This can often happen from birth defects like tetralogy of Fallot, where there are heart defects that are not allowing oxygenated blood to get to the tissues. This is really an emergency situation. So as a nurse, for example, anytime you see a patient looking blue, that's serious. You better figure out what's going on. This person is not getting enough oxygen to their tissues, which in itself is bad enough, but it may mean there's an underlying problem with the heart or with the lungs. It could be quite serious and could be potentially fatal. So, see, skin color actually very important. And a little bit more here, another skin color thing. We've got erythema, or erythema. Pronounce it any way you want to. I think erythema is the more traditional way to pronounce it. I actually usually say erythema, just my personal preference. But there you can see it's often what you would call a rash. It's a redness of the skin due to enlargement of the capillaries in the dermis. It'll occur with inflammation, infection, allergy, burns, so whatever, poison ivy, you're allergic to, you get hives, contact dermatitis from latex or something like that. A lot of different causes. So in and of itself, it doesn't tell you what's wrong. It just tells you that, for some reason, the capillaries near the surface of the skin are dilated. But at least it tells you that there's something going on, and you better look a little bit further to make sure to see whether or not it's serious or whether it's not serious. Okay.